So the first thing we're going to do is the power rule, which we have already kind of discovered, but we're going to extend it to some different types of problems. The power rule. The power rule is the only rule we have, okay? We don't do trig derivatives. We don't do log derivatives. We don't do E derivatives, okay? We do power rule derivatives, okay? So the first thing we're going to do is just write down the power rule in a couple different formats so you can recognize it, and then we'll do some examples, okay? Power rule. All right, so, and this is as much for like notation as reminding you what the rule is. Okay, that's x to a power. The prime is the derivative, and that is just the power rule, which means drop the power, subtract 1. Okay, that's the power rule. Okay. Okay, that's using f of x, which is function notation. I'm going to use y equals x to the n, which is just a different notation, but it's still x to a power. And this one says dy dx. Notice that that looks like slope, dy dx, okay? Which is drop the power, subtract 1. Okay, this is just notation. All right, that's all this is right now. So the derivative, right? It's just different ways to identify the derivative. F prime, dy dx. And now there's one more way to identify the derivative, okay? And it looks like this. Let's see if I can make this fit. No, I'll do it underneath here. D dx, parentheses. Notice how it looks kind of like this dy over dx, but I left off the y. Instead, right, y equals x to the n. This whole thing means find the derivative of this thing in the parentheses. So this is a notation. D dx, the derivative of this thing, is the power rule. Okay? So these are different ways to ask for the derivative. Find f prime. Okay? Find dy dx. Find d dx of the thing in the parentheses. They all mean do the power rule. Okay, so I'm going to write the power rule like in a sentence because sometimes words are easier to remember than a formula. So drop the power, subtract 1, okay? Or multiply the power. Multiply the power, subtract 1. Oh, that's a B. Power format. Looks like a polynomial. Okay. Okay. Power format. Looks like a polynomial. Okay. Now let's be specific. X is in the numerator. Notice how none of the x's in a polynomial are in the denominator. That's important, okay? So x is in the numerator, okay? Exponents can be any number. I just said looks like a polynomial, okay? But coefficients can be any number. Exponents can be any number. Because so far we've only looked at problems that have positive integer exponents. Today, we're going to expand that to negative exponents, radicals, fraction exponents, and we're going to do the power rule with each of them. Okay, so let's just do one example with this polynomial. Okay, y equals 3x 8 minus 1/4 x to the 4 plus 3 over 2x squared minus 5x plus 1. Okay. And we're just going to write the derivative. I see that the notation is asking for the derivative.
So this is like going back to what we did earlier.
Yes, but we're gonna extend it right after this example. Okay, so we're just sort of connecting to what we've done, and we're gonna do more with it. Okay, so the power rule says drop the power. Right, so multiply the power, 24, x, subtract 1. Now, most of these polynomials you can do in your head because you're just multiplying integers. Okay? Drop the power, so 1/4, okay? 1/4 times 4 is 4 over 4 is 1. Okay, so 1x cubed. Okay. 3 over 2 times 2, right? Multiply the power. So that's 3x1. All right, so just as a reminder, everything with an x affects the derivative. So if I were to multiply the 1, I get minus 5, but then the exponent goes to 0, which means the x goes away. Notice how the 1 doesn't have an x. That means that there's no power rule. It means nothing happens with it. It goes away. So this is the derivative. Okay, that part was review. If you have a separate color or a highlighter, that would be useful because we're just going to identify 2 parts in this next set of examples. Okay, you could also just underline. It doesn't have to be super colorful. Okay. Here we go. C. Reciprocals. Okay. To power format. So we're going to just draw a few examples of how to convert. So if I have y equals 1 over x, that is not power format. Okay, it doesn't look like a polynomial because the x is in the denominator. So what I need to do is I need to take this and it has to move to the numerator. Okay? So this is a 1. In order to change locations, you change the sign on the exponent. Notice how this 1 is going to stay, okay? And the x is the piece that's moving. That was supposed to be a times, right? That is power format. X to the negative 1. Okay, in order to change the location of the x from the denominator to the numerator, the sign on the exponent changes. Okay, so all we're doing right now is we're just looking at how to get from a reciprocal, which is an x in the denominator, to a power format. Okay, so let's try 3 over 4x. Three over 4 doesn't move. Okay? The only thing that is moving is the x. So the exponent becomes negative. This is the power format. Notice how it kind of looks like a polynomial, except the exponent is not a positive integer. All right, let's look at maybe... No, I think that's fine. Okay. Examples. Okay, so I'm going to put a little note. Negative exponent changes location. All right? Changing that exponent is how you move that denominator to the top. Find the derivative. All right, we're just going to do a couple examples. I think 5 of them, actually. All right. Here we go. If I want to use the power rule, it has to be in power format. So the first thing we're going to do is change it to power format. Okay, so the x needs to move. Okay, that's the part that needs to move. So we get x to the negative 1. Okay, here's where I'm going to use my second color. You can either like underline it or highlight it. Now I'm going to do the derivative. Okay, notice up here, both blue, all I did is rewrite it. I haven't done anything but rewrite it. Now I'm ready for the power rule. Multiply the power, subtract 1. Don't write too small because you've got coefficients and exponents smushing together here. Okay? Okay. Put it back into reciprocal format. Okay. So the negative 1 stays and the x, right? This is the only thing that's moving. So if you want to move a numerator to the denominator, you change the sign. Okay, so this becomes x squared in the denominator. All right, this is the final answer. all the way back to the reciprocal format. Okay, this is where we started. Usually, whatever format you start with, that's the format you end with. But you can't use the power rule unless you're in power format. So you have a lot of rewriting to do on these problems. Okay. Here we go. Y equals 2 over 3 x. Okay, rewrite it. I'm going to circle the x because that's the only thing that has to move, not the coefficient. 2/3 x to the negative 1. Now, I prefer putting my x in front of the number, okay? I don't like to write it like this, okay? I don't like to write it like that. I like to write my coefficient in front of the x because it looks easier to me in terms of doing the power rule, okay? So, not my favorite way to write it. I find this to be a lot easier, okay? All right, the derivative, right? I'm switching colors because there's a lot of rewriting here. You want to make sure that you know when you've done the power rule, okay? Multiply the power, subtract 1. Right, we're still kind of mostly multiplying integers here, so we can do it. Okay? Put it back. Okay, so the only thing that's changing is that part. Okay, so it's going to go from the numerator to the denominator, and so the sign changes when the location changes. All right, so I'm just sort of boxing where we started and the final answer of the derivative. Yes, question. Yes, because there's only one negative. If they are both negative, then they would cancel out and be positive. All right, here we go. 4 over x cubed. This time you try it. Okay, so I'll give you some blanks. We got to rewrite it. We got to do the derivative. We got to rewrite it. All right, this time you guys are going to help me. All right, Pedro, how do I rewrite this into power format?
You would bring the x to the top, and then it would go to x minus 3.
Okay, x to the negative 3, yes, okay. Dylan, how do you do the power rule? You can either tell me simplified or unsimplified. How do you do the power rule? Okay, so can we say negative 12? Okay, x, and then what's the power? Oh, yes, okay, yeah, be careful because we're subtracting 1 from a negative. Right, Olivia, how do you rewrite it into reciprocal format?
Y equals negative 12 over x for x to the power.
Yes, all right. Okay, there you go. Okay, question 4. Y equals negative 7 over 2x squared. Okay. Rich, right? I'm going to call on 3 people, 1, 2, 3, for answers. Vote a friend while you're working, if you need to.
Is it negative 7 over 2x squared?
The negative would go in one of the places. Either goes with the 7 or the 2. But it doesn't go with both. You pick. I usually put it with the numerator because that's
Okay, no, plus
typically what happens. Okay. That's only one question at a time. I'll lead you. You can either answer or ask a question. How about that? Yeah, be like, okay, like if you're confused, be like, okay, where does this go? Should it go like this or like that? Right? Usually you're stuck between 2 choices. Okay. First question. Maya, can you tell me how to put this in power format? X to the what? Yes. Okay. Awesome. Coefficients didn't move. The only thing that moved was the X. Perfect. Okay. Next. Silent, can you tell me how to do the power rule from here? Yes, it is. I'm going to do something else first, but that is correct. So this comes down. When you multiply something with a fraction, you multiply straight across, which is how she got 7, positive 7, because the 2's reduced. You could have also said negative 14 over 2 if you didn't catch the division at first. Totally fine. And yes, x to the negative 3. Okay, so for the final answer, Ian, can you reduce and rewrite it?
Is it positive 7 or negative?
Up. Thank you. Okay, Ian, can you reduce the numbers and put the x in the correct spot?
Yeah, 7 over x cubed.
Yes. Awesome. All right. Feeling pretty good. This one's not too bad. Right, it's almost exactly like polynomials, but you've got some negative numbers. Now we're going to add radicals. You can do it. Okay. All right, so I'm going to flip my page. A, B, C, D. Radicals. Radicals. To power format. Okay. Here we go. So we're just going to write how to put them in power format first. So we have a root x to a power. Okay, so all I want to do is, this is the part that's going to move, the root. Right? So x to the p doesn't move. The only thing that moves is the r, and it goes to the denominator. That's it. That's how you rewrite it. Just like that. Okay. Now, we have to sort of put the two pieces together. Okay? 1 over root x to the p. You can do this in 2 steps. But I'm going to do it in, I suppose, 1. You can, but guys, you can do this. All right, notice how the x to the p is in the denominator. So that has to move. How do you move an x from the denominator to the numerator? Negative exponent, right? I have 2 circles, so I'm doing 2 things. First, I'm moving the location of the x to the p from the denominator to the numerator. Then I'm moving the r. Okay, I had 2 things that I was moving. All right. All right, y equals okay, square root of x to the 5th. All right. Notice how x to the 5th is a positive exponent and it's in the numerator, so I don't need to move it. The only thing I have to move is the root, which is a square root. Okay, so that's this part right here. So it's going to go x to the 5 halves. That's my power format. Now I'm ready for the derivative. Okay. Drop the power. Subtract 1. Okay, if you need your calculator or scratch paper, go for it. Okay, so I'm going to do the arithmetic right underneath of this, just as a little scratch work. So 5 halves minus 1 is minus 5 over 5, which is negative. Nope, sorry. Boop. Yes, thank you, because I'm silly. Woo. 2 over 2, thank you, which is 1, which is positive 3 over 2. Okay, there's my subtracting 1. This is the 1. 2 over 2 is 1. Drop the power, subtract 1. All right. Put it back. The root is the only thing that has to move. Okay? Powers and roots can kind of move separately here. So put it back. 5 over 2 square root x cubed. And it is okay to leave your radical like that. We're not focusing on simplifying our radicals. We're just focusing on doing the power rule and putting it back into that format. Okay, so we started here. I started with a radical. I ended with a radical. Okay, let's go with 3 over 2. Okay. Cube root x to the 4th. Okay. I know, it's, guys,
No, I was busy.
No. no, it's fine. It's the fractions and the arithmetic. That's what it is right now.
This is disgusting.
I know, it's not your favorite. Okay, here we go. X to the 4/3. Okay, there's my, right, looks like a polynomial. Number x power in the numerator, right? It has to be in the numerator. The x has to be in the numerator. So now I'm ready for the power rule. That's why I'm switching colors so that you can tell when I'm actually doing the derivative. Okay, so drop the power. This is sort of up to you, right? So I multiply those two things together. You can either do it in your head or you can write it down. I end up with just 2, right? Which is 12/6, so 2, okay? X, okay, subtract 1. 4/3 minus 3/3, right? Because it's the denominator that has to match, is 1/3. Put it back. Okay, the only thing that has to move is the root because x already has a positive exponent. There's no moving there. Okay, so it's 2 cube root x. Here we go.
I'm worried about a step. Not like it getting it back there. Oh no, I don't like this. It's Estelle's doing.
Okay, so let's do
No, it's
4
TSA
thirds.
I don't think she was allowed.
X cubed. Yes, I can.
Thank you.
And let's make this a power root. Sure, let's make it an 8. Well, that's really small. Let me try writing that again.
What is that?
It's an 8. There you go. It's an 8.
Wow.
Okay. Okay. Zoomed in. I don't know. All right, guys. There are 2 things that have to move. Notice how x is in the denominator? So that has to move. And the root. Both of those things have to change formats. So when I rewrite this, the 4/3, it just stays, right? The coefficient just stays there. But this, x to the -3, because the location needed to change. And the root had to move. Numerator and denominator is a reciprocal thing, the negative exponent. The root just becomes the denominator of the fraction. Okay. Now I'm ready for the power rule. Okay, so, right, drop the power. Right, there's me multiplying the power so that I can reduce it. -1/2 x subtract 1. Okay, subtract 1. You always are matching the denominator when you do this subtraction. Minus 11 over 8. Okay. Oh, 2 negatives. Okay, so I got this negative. Power is negative, and the root is 8. Means I have to do 2 things. The negative power has to move numerator to denominator. Okay. Equals. All right, so I'm just going to start by writing my minus 1/2. X to the 11th, right? Because it has to change locations. And the root is an 8. Whew. Zoom out a little bit. Okay. All right, we're going to do the 4th one, which is our last one, because I know we're coming up on our time limit here. Okay, sometimes all the exponents are positive. Sometimes the exponents both end up negative. Sometimes only one of them could be negative, and that's what I want to show you. Okay. 4th? All right. Y equals 4/3 5th root x cubed. So the coefficient goes nowhere, okay? X cubed is in the numerator already, so it's just the root that I have to change. X to the 3/5. Okay? Now I do the derivative. So 4/3 times 3/5. Okay, so that's 4/5. Right, this is my scratch work. Okay. Subtract 1. X to the negative 2/5. Oh, okay, so I have a negative exponent and a root. So both of those things have to change. Okay, so the 4 and the 5 don't move, right? There's no exponent with that number. So x to the negative 2 moves to the denominator. Yes? Here?
Yeah.
Okay, do you see how the x is already in the numerator?
Oh, okay, yeah.
Nope, that's fine. Good question. Okay, the negative and positive deals with top or bottom of the fraction, and the root is the denominator of that fraction. Okay, and 5th root. Yeah. Okay. Whew.